Then I saw your face, your forgiving eyes, looking back at me from the other side, like you understood me. And I'm never letting you go. We all need that someone who gets you like no one else, right when you need it the most. We all need a soul to rely on, a shoulder to cry on, a friend through the highs and the lows. I'm not gonna make it alone. La, 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 la. I'm not gonna make it alone. La, 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 la. I'm not gonna make it alone. I'm not gonna make it alone. I'm not gonna make it alone. La, 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 la. I'm not gonna make it alone. La, 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 la. I'm not gonna make it alone.
The club isn't the best place to find the lovers, so the bar is where I go. Me and my friends at the table doing shots, tripping fast, and then we talk slow. And you come over and start up a conversation with just me, and trust me, I'll give it a chance. Now take my hand, stop it, and the man on the jukebox, and then we start to dance. And now I'm singing like, girl, you know I want your love. Your love was handmade for somebody like me. Come on now, follow my lead. I may be crazy, don't mind me. Say, boy, let's not talk too much. Grab on my waist and put that body on me. Come on now, follow my lead. Come on now, follow my lead. I'm in love with the shape of you. We push and pull like a magnet do. Although my heart is falling too. I'm in love with your body. And last night you were in my room, and now my bedsheets smell like you. Every day discovering something brand new. Well, I'm in love with your body.
Good morning. How is everybody? Good. I'm ready for a good day over here on my end of things. Gonna go ahead and pull up. Where did our board go? Where's my active board? Yeah? Oh. Let's see, where did it go? Pop up this Freyer model. It used to be up here. There it is. Go ahead and add some things this morning to this. And add more to our definition. Let's add more examples. We just got to get that cat in there, don't we? Is JB in here yet? If he wants to, I don't see JB yet. We'll go ahead and, it is super foggy out. Let's take a couple of minutes and have you fill this out for proteins. Having a harder time than normal this morning. Some mornings are tough. I think the sunshine always helps me. Take a couple minutes. I want to go ahead and make sure. Again, add to this board for me. Examples, a definition. We can still fill this up with non-examples. What is not a protein? That's just as important as knowing what a protein is. Believe it or not, there is some protein in cheese. Don't think about it, but there really is. Awesome. That looks great. Oh, you're having a harder time typing. I see, Kaden. Sorry. That makes more sense now. Hey, Milo, will you come over here for a light? I want to make sure we have good lighting, and I want to tell everyone why today is one of our favorite days. Why is October 5th one of our... Whoa, that was a lot of light. Maybe leave it like that. Come on over here, Mila. Nope, turn that one off. Come on over here. Tell everyone why October 5th is one of our favorite days.
Because it's my birthday.
It's her birthday. It's Mila's 7th birthday today. Yes. Thomas knew it. He had a suspicion. It's somebody's birthday. Oh, it's Kinsley's dad's birthday today, too. Oh, look at all these people saying happy birthday to you. I have to go back and read you all their names. Thomas it's his sister's birthday tomorrow. How special. Oh, look at all those people saying happy birthday to you. Say, Mila is my first baby ever. So 7 years ago, she made me a mom. It was probably the best day ever, huh? Yes. Awesome. So yes, it's October 5th is a special day for me. Sounds like you all have some special people in your life that have some birthdays coming up too. Thank you all for making her feel so special. Today, we are going to look at our last group of our last macromolecule, should I say? We looked at first, what was our first macromolecule that we looked at? Type it in chat to me while this loads up here. What is our first macromolecule that we looked at? Yes, carbs. Our delicious carbs. Give me your favorite carb in chat. My favorite carb would probably be, I don't know, maybe pancakes or waffles. Breadsticks, pasta. Yes. All of these things are good carbs to me. Ooh, matcha bread. Peanut butter. Jana's here. Good morning, Jana. It's talking about our favorite carbs. I actually really do love birthday cake. Might be one of my favorite carbs too. What kind of cake is your favorite cake? I like white cake with any kind of frosting. Ooh, almond. Olive Garden breadsticks or Fazoli's breadsticks. Yes, that is where it's at. Sweet. All right. So we are on Tuesday. All right, today we are going to finish up our last macromolecule, nucleic acids. Tomorrow, as promised, tortilla chips. I'm big into chips and salsa. Chips and queso. Yes, I'm there with you. White cake with sprinkles. I'm there with you too, Kensley. That I know it's making me hungry. Awesome. So today we have a short quiz after class. Make sure you take that. Okay. Yesterday we had a short quiz. If you did not get those done today because it's going to give you a good gauge of what you need to be preparing for. Because Thursday we have our Unit 2 test. All right. The study guide, is it mandatory or is it optional? Do you have to do the study guide? So many people will email me and ask me. No, it is not mandatory. It is completely optional. All right, so know that, but know that it also has test questions on it. So if you want to do well on the test, it's a good thing to at least open that sucker up, look at it, see if it gives you a good idea of where you are at. Hey, Mila, no skip it during class, baby girl. Okay. Who would like to read these goals for me today? Who's going to read our goals? What are we going to know by the time we leave this place? Jana's got us some music. I have a good spot for us to listen to that music here in a minute, Jana. Who would like to read these? Somebody? Anybody?
I have my hand raised.
Oh, I'm sorry, Kaden. I'm scrolling through the list. There, I see it. Thank you. It takes me a minute. I have to scroll through the ribbon at the bottom. Will you go ahead and take it away, Kaden?
Okay, dear. List the ways RNA is different from DNA. What is the role of DNA in the body? How does the structure of ATP provide energy to the cell?
Yes, we have an accent in the house this morning. Awesome. Perfect. So we're going to look at DNA today. One of my favorite things to study in science. We're going to take a peek at it today and look at it further in the unit. But yes, I think it's just going to be enough to get us hyped about it today. I was going to do a diagram like this for each of our macromolecules to get our brain going, but we're not going to because I'm afraid we won't have enough time. So what I would like to do instead is start with nucleic acids this morning, okay? Write what we know, and then we're going to fill this out at the end of class, and we're going to be like, oh yeah, we are so much better now that we've had Mrs. Rittenhouse's awesome lesson. Okay? So, Jana girl, let's listen to some of the music you have created for us. While we fill this out. So you have board tools. You might not know a lot about this right now, but you probably know something.
By the way, warning, it has some screeching noises in it because it's for a villain in a play I'm writing for Moriarty because I'm writing a Sherlock Holmes play.
Cool. That's all right.
So yeah, there's some screeching. Warning.
Anyone who gets frightened easily Ooh, ghosts because they aren't real. I like it. And that is true. I actually really like that. So ghosts are not a nucleic acid. DNA is an example of a nucleic acid. Good. Rocks. Rocks. I love where we're going with this. I know that you guys probably... Good. Things that are not alive are good non-examples. Somebody write rocks up there. Aliens. Ooh, cytosine. That is a good word to throw up there. Shania, I'm impressed. Good. Proteins are a non-example. Was that me? Did I write that on there? People. Good. Thomas, that's great. Deer. Yes. Wendigo. I don't know what Wendigo is. Help me, Kate.
A Wendigo,
Does that mean I'm old?
a Wendigo is a type of cryptid, kind of like Mothman and stuff.
Okay, okay.
I put Mothman, but I've been really into the Wendigo. Even though it's like really
Perfect.
deadly. Not real.
See, Jaina, your like spooky music is inspiring us. It is inspiring us this morning.
Actually, Jane, it is
Good.
kind of inspiring that Wendigo theme.
Absolutely. Awesome. RNA. Yes. All right. Well, let's move forward. Thank you, Jaina, for sharing this morning. That's pretty awesome. I'm pretty, I like to sing and I like music. I don't know that I've ever created music like that. So I'm in much admiration of how you can put all those pieces together. All right, so this unit we've looked at carbohydrates. We know that they're sugars. What is a type of sugar that carbohydrates are made of? We did some word dissection. Mono what? Mono saccharide. Good, almost there. Yep, it is a molecule. Monosaccharide. What is another? Good, disaccharides. Excellent, Maria. What is a saccharide that has more than two? You have mono, di, and yes, polysaccharides. High five to all of you. Good. So those are all examples of sugars. Our sugars contain carbon, hydrogen, and oxygen. All right. We also talked about lipids. What's another name for lipids that is more household familiar? Right on. Fats. Lipids are fats and oils. What are lipids important for in life? Why do we need lipids? Why do we need fats? Good, they're important for stored energy. Perfect. Yes. Energy and what else? What is it at a cellular level? What do we see? Where do we see lipids? Perfect. In our cell membranes. Good. And then what about our proteins? We learned that our proteins, they're made of amino acids, right? We talked about those on last Wednesday. They look like beads. That's the identity of proteins, are our amino acids. And what else are they important? Oh, yes. Good, Alex. They're important for that activation energy. They go in and they speed up chemical reactions. Enzymes speed up chemical reaction. We talked about like that little referee with a whistle or someone with a whistle that's like blowing a whistle, or that little rabbit from Alice in Wonderland. It's like I'm late, right, for a very important date. And he's running around and he's all crazy. Good. Excellent. So our proteins are important are made of amino acids. We need to know that. Have any of you ever heard of collagen? Collagen. Collagen is a form of protein. Collagen is a form of protein, and it's different from the protein that we need to build our muscles. All right. Collagen protein lacks an amino acid that the protein that we get from, like, let's say chicken, or the protein that we would get from hamburger meat, the protein that we would even get from some plant proteins. All right. So that I found very interesting. I just learned that out lately. Our collagen is more important for our hair, skin, and nails, and it is important and differently important for our hair, skin, and nails because it lacks an amino acid that we need for, like, building. Like, if you were gonna go do some lifting today, if you're gonna work out your biceps, what happens when you work out your muscles is you actually tear the muscles in your arm. And once you tear that muscle, you have to repair it. And you repair it by the protein that you eat or consume. That's what rebuilds the muscle. And when you rebuild your muscle, does it stay the same or does it get bigger? What do you think? When you tear your muscle and it repairs, absolutely, Madison, it gets bigger. It doesn't, Caden. It really does. It does get bigger. Awesome. All right, so the last thing we're going to look at today is our nucleic acids. Why our nucleic acids are important is because of our DNA and RNA. All right, everybody type let's put nucleic acids, or you can put Na, okay, equal DNA/RNA. DNA and RNA. DNA is in every single cell of your entire body. Look at your arms. You have millions, billions, trillions of cells in this small sample of your body that we're looking at. I don't have a Quizlet, but I do have a word wall game that has all of these vocabulary words, okay? Putting it in chat right now. We can play, not now, but you can play after class, okay? DNA is what makes you who you are. All right, all you brave people, that would be willing to put on your webcam this morning. Will you? Let's look at some of our traits. All right, I'm seeing Peyton. Peyton, do you have brown hair? Color hair, you have brown hair? Yes. All right, so I'm looking at Peyton, and she has brown hair. I know she has brown hair because I'm seeing it, but the reason she has brown hair is because it codes for it in her DNA. Looking around for some of you. Where are you? Anyone else out there? Oh, Kaden. Kaden has a mask on. He is not webcam ready this morning. No. I see. Kaden, do you have blonde hair? Like dark blonde hair maybe? Or you have brown hair? What color are your eyes in those little holes of your mask? Kaden has blue eyes. Kaden has blue eyes and brown hair. Good. Because his DNA codes for that. Still looking around. Peyton has, ooh, like a brownish green eye. Thomas has black hair. Thomas has some curl to his hair. I wish I had some body to my hair, Thomas. I'm jealous. And that codes for it and his DNA. Just like my hair is super thin, super fine, that is coded for in where? My DNA. Yes. Jana has some thick hair too. Yes, your dogs. Your dogs is, do we have a dog? Do we have Caden's dog back in the house? Yep. Caden's dog, it has DNA too, right? It's living. Caden's dog is brown because of what his DNA is coding for. Is your dog a boy, Caden, or a girl? He is a boy. And did you know that your gender is part of your DNA as well? So that's something else that is actually attached in your chromosomes based on your DNA. Your DNA makes up everything about you. Let's do a quick poll. Green check if you are short. Red X if you are tall. Green X if you are, or green check if you are short. Red X if you are tall. I'm going to show this. Ending in 3, 2, 1. Peyton, I don't know what that just, I am 5'2". Is anyone in here shorter than 5'2"?
So, being tall is actually a recessive trait, while being short is a dominant trait.
Look,
I have a recessive trait.
yes, good. And we're gonna.
I'm 5'7" and a half.
Awesome. So Jana's tall. I'm a shorty.
Legit 5'10".
I love it. Jana, did you get a haircut? No, I was feeling like your hair was longer for a minute, but maybe I just haven't. I was like, I think it looks different today. It looks super cute. I love it. So some of you, there's some shorties in the house with me. Oops, I didn't mean to switch our slides. So yes, we're going to talk later on about how your traits have dominant and recessive characteristics. Barely 5'3". Alex, I'm barely 5'2". I'm like 5'1 and a half, but I always round up. All right. What do I need you to know about DNA and RNA today? There are different information about both. We are going to study a lot more about DNA and RNA this year. But what I want you to know for Unit 2 is that DNA and RNA are made of nucleic acids. All right. And the difference is DNA is a double string. It has a double strand. D equals double. That's how maybe you can remember. D equals double. Okay? DNA is a double-stranded helix. This right here is our DNA. All right? If we unwound it, it would look like a ladder. All right? If we unwound RNA, you would see that it's only one strand. So what I really need you to take from today is that DNA and RNA are important because we need them to live. All right. If a cell does not have DNA, can that cell live and function and grow? Yes or no? You're right, Maria. No. Your DNA is like the brain for your cell. It has all the information. It tells your cell what to do. It tells your cell when to divide. It tells your cell when to make certain proteins. It tells your cell, it's the complete instruction manual. And if your cell does not have DNA, that cell will die. Okay? We talked about some proteins the other day, and if they get too hot, how that denatures them or kills them. If you kill any part of that DNA of your cell, oh, Bryce, that is such a good question. Does coronavirus have DNA? Coronavirus has RNA. Okay. Now, viruses in general, not just coronavirus, but even like the flu, okay, coronavirus and any virus, it is debatable as to if viruses are technically living things, okay, because viruses cannot live without a host. Viruses cannot live without a living cell. Does that make sense? So viruses need you. All right, they need your cells. And that's why they transfer from person to person or person to other living things, because they need living things to be transferred. Okay? Always say COVID, like we say coronavirus, and everybody is all of a sudden paying attention. So yes, viruses do have a form of genetic information. All right. That's what gives them their identity. But they have this RNA, they have this single stranded stuff. All right. So what do we need to know? DNA is how many strands? DNA equals how many strands? Type it to me in chat. Get on your mics and say it. I hear Mike. You can say it. DNA has how many? Two strands. And RNA has how many strands? One. Good. So eventually, if we get to the end of this lesson, I should technically be able to cover up this. Oh, crud. Cover this up down here, but of course I'm like not doing this well. And you should be able to tell me that this is DNA and this is RNA. All right, you'll see all these little colorful things to the side. Does anybody know what these are? What are these? Anyone know? Uno. I like it. These things off to the side are what we call nitrogen bases or nucleotides. All right, we're going to learn all about those later. All right. So let's make a quick chart. What is the same and what is different between DNA and RNA? This should be real quick. So how many strands does DNA have? Somebody throw it up here on the board. Ooh, Alex, good. Put that on the board.
Okay.
That is so good. Good. Both RNA and DNA have nucleic acids. Perfect. DNA, yes, deer have DNA.
Oh, I'm
Somebody
still
put
on
how
mic.
many strands are in DNA up here, and how many strands are in good. How many strands are in RNA? Thank you, Shania. What about RNA? RNA has what? How many?
One strand, or
Yes.
something less than 2 at least.
Yes, one is perfect. Yep, it has one strand. Somebody write one up there for me. Good. They also both have those nitrogen bases, those nucleotides. You guys want me to write that up there? Since it's kind of a tricky word. Ooh, not nucleotides, nucleotides. Okay. They both have nucleotides. Good. So DNA has 2 strands, RNA has 1 strand. They both are nucleic acids, and they both are made of nucleotides. Awesome. Throwing up a smiley face poll. How are we feeling about knowing that DNA and RNA are nucleic acids, that DNA is double-stranded, that RNA is single-stranded, and that they code for who we are? It's basically the brain or control center of the cell. Good. It looks like most of us are getting there or feeling decent about it, which is good. Good, good, good. So let's keep moving to the very, very last piece of today. Where'd it go? Where's my slide? Oh, here it goes. That picture didn't pop up. All right, ATP. ATP. Everybody type ATP. ATP is taking us back. It's taking us back to the beginning of our lesson when we talked about our favorite carbs. All right? Our favorite carbs, because our bodies, our cells make ATP from where? Where do we get our energy? Where do we get our energy? Yes, carbs and fats. Perfect. Carbs and fats. Absolutely. So why do we eat carbs? Why do we consume fats? Well, we do it for our cells because our cells break down those mono, di, and polysaccharides, those simple and complex sugars that are either stored in the fat of our body or consumed as carbs during the day. And they take them and break them down and make ATP. All right. ATP is the energy for the cell. If you go to Mexico and you try to pay for something with an American dollar, will that work? Yay or nay? No. All right. You can't use American money in Mexico because they have a different currency. So we put sugar in our body, and our body, although it doesn't use that form, it converts it, right? So if I choose to go to Mexico, I can take my American dollar, I can give them my money, and they will convert it to pesos that I can use in Mexico. And it's the same thing in our bodies. Our bodies take in sugar in the form of glucose, sucrose, all those oses that we talked about. And they use those and they convert them to ATP. So when we're talking about cells and living things and the energy that we use on a cellular level, I want you to just know ATP equals energy. ATP equals energy. Can you type that for me? ATP equals energy. I like making things simple for you. All right? ATP equals energy. DNA is the double-stranded nucleic acid. RNA is single-stranded nucleic acids that tell our cells what to do. And that DNA will actually tell our cells to take glucose and to make ATP when the cells need it and when glucose is available. All right. Which statement best describes the role of DNA? Which one do you think? Does it transmit genetic information? Is it directly forms proteins? Does it form energy? Or does it speed up chemical reactions? Genetic information is going to be, genetics are what tell your body to have a certain color of hair or eyes. Genetic means genes. Anytime you see that word genetic, I want you to associate it with DNA. All right? A is the correct answer. A is the correct answer. Genetic information is stuff about who we are, all right? Our identities. True or false? We're going to use A and B for true and false. Does DNA translate the information in RNA to make proteins? You know what? We're going to skip this because we didn't talk about that. The answer to that is true, okay? This is true. We didn't go into that today. We're going to go into that in our next unit. But our DNA tells our RNA, it kind of gives us basically a copy. RNA is a copy of DNA. All right, and we use those copies to go to our ribosomes and our cells to make proteins. All right. The next is which statement best explains how the structure of ATP helps provide energy? Okay, I'm going to tell you this one as well too. ATP contains energy in bonds. It's going to be B. ATP contains energy in bonds. We talked about ionic, covalent, and hydrogen bonds. Anytime you form a bond, that bond represents stored energy, okay? So when we rip bonds apart, when we break bonds apart, what is released? Say energy. 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 Good. That's why ATP is energy, because the energy is stored in those bonds of ATP. All right. Good. All right. Do you think we can do a better job at this? Yes. When you are a bond breaker, Kaden, when you're a bond breaker, when you break a bond, you release energy. It's like an explosion of energy. Good. Yes. And there's more of that to come in the future units. Unit 2 is kind of a taste of everything that we're going to take to a greater level. All right. But on a living component. We're looking at these 4 molecules that are important for all living things. And then we're going to take each piece and look at them a little bit more in detail. All right, so a characteristic of a nucleic acid might be what? those nitrogenous bases. Nucleotides, perfect. All right, nucleotides. What else? Let's fill this bad boy out right here as we leave. All right, we are going to go ahead and do this as we leave. Good. It can be one-stranded as a characteristic. Good. It could also be what? Double-stranded. DNA and RNA. Good. You can still use some of those examples like rocks that someone said. That can still be a good non-example. I don't know, Kaden. I think something is a little funky with Neuro today because it's doing the same thing for me. Is anyone else having a hard time with the typing tool? I'm typing and it's not going on. Lovely. Well, that's going to slow things down, isn't it? Oh, gotta love it. All right, so list the ways DNA and RNA are different. You did that. You are awesome. What is the role of DNA in the body? What is it? It's the genetics. Yes, it's like the brain of the cell. Good. And where does ATP store energy? In the ATP stores energy in the yes bonds. Bonds. All right. We are going to review all of this tomorrow. I have a Kahoot ready for you. If you need that link again for the word wall. This has all of those terms in there that we've been talking about. Okay? So make sure you go in there, play that game. It'll be fun. It'll make sure you're ready for all of our vocabulary words and for our test. Oh, our test on Thursday. Thank you, Jasmine. I will be sending out today a matching PDF, and then that will also give you a printout. Do you all like printouts? Is that helpful to you? I'll send a printout too that you can use if you're a pencil paper person and you need it in front of you. Have a wonderful day, guys. October 5th, it's a good day. A good day for a good day. I will see you tomorrow morning. Thanks for working so hard today. Bye, guys. Thanks, guys. Bye, Katie. Bye, Leah. Thank you, Madison. You too. Yes, Emma, that is correct. Yep. You guys just have that quiz to complete for today. Read those lessons and play my little review game if you'd like to help get you prepared. Oh, remind me that, Alana. I would love that.